Hello, we are happy to present you another release of the module application. It will help you to master CNC programming. Let's look at the application menu. The first three functions of the menu are processing modes. The first one is turning mode, the second one is milling mode, and the last one is drilling mode. Let's have a look at turning mode. This is a menu. Here you can select one of the materials to be processed in the database of the app. Any material: steel, stainless steel, cast iron, soft materials, hard steel, and special materials. After the material has been selected, we choose the processing modes. What we can set? Now we need to choose the parameters. We need to choose diameter of processing, which is the minimum turning diameter for processing. The second parameter is cutting speed. You can set the parameter manually, or you can choose data from the table of materials. The third parameter is the max spindle speed. It's possible to calculate cutting speed knowing the spindle speed. This way. Also, you can set feed and tool radius. Feed is set according to the demand of the roughness of the surface. As you can see, in this case, the roughness of the surface 1/56 micrometer. Moreover, here in the table you can see correspondence of data to the class. Also, it's possible to calculate plate durability while processing the material. That requires setting of a bar diameter, for example 23, turning length 50, and also the depth of cutting in one pass. In this case, we got a number of pieces which we will process. 456. This is data from the database of the app. However, if you conducted tool testing beforehand, and you know that this cutting mode gives you 300 pieces, using these modes, you can directly calculate tool durability. Okay, 300 details pieces. You need to add your material as a new material to a database. And you get durability in meters and in minutes. It gives the following results. If you want to make more pieces, for example 400, and you add your data to a database, you can convert this number to a cutting mode. Respectively, the cutting mode changes. Speed of cutting and spindle speed change. And this way you will be able to do these 400 pieces. But if you want to double the speed of cutting from 200 pieces to 400 pieces, for example, Then you will be able to calculate how many pieces you get. You can see that you will be able to make 10 times less pieces. And this is always important because you will calculate correctly the processing modes considering a number of pieces which you want to make. So this app is really beneficial for determining economic feasibility. In this or that case. And tool durability calculation allows to save money and to cut down expenses in the manufacture of the product. You will be able to use the tool efficiently. And you will understand how many pieces you've made and how many pieces will be made, and which modes are more efficient. And here you can see that it's more efficient to buy a second machine and to process the material using two machines. This way you will get twice as much pieces. It's better than to constantly speed up. That will lead to the tool damage and the expense on tools will increase greatly. We're moving on to mill conditions. And this mode is similar to the previous one, as you can see. However, there is a possibility to select an option, an end mill, a solid mill, a drill, and high-speed milling. You make a choice and you make calculations. Going on. The drilling mode, you can select carbide drill, solid carbide drill, or high-speed steel carbide. There is a table as well, and knowing the number of holes you drilled using certain modes, you can calculate your tool durability. You add new material to a database. Here you can see the durability of your own drill. If you want to make more holes with this drill, you can convert the number of holes to the cutting mode. For example, 350. Moving on. There are patterns, turning patterns, turnmill-patterns, and milling patterns. Let's have a look at turning patterns. Here the method of module programming is applied. You choose a certain pattern, set parameters, choose certain steel, and insert module in the list. Right now the list is empty. If you want to edit something, you can do it right away. But if you're not satisfied with something, you return, delete the module, and then edit the pattern once again. And then you add a new module to a list. Moving on, drilling. You open the list and see that a previous module is saved. Now we are adding a new module. A new module, drilling. You can edit anything you want. When you need to save a file, we press save. And the file is saved to the app folder. The app will save a file. But you need to give a permission to the app to access the storage of your phone in the settings of the phone. So we need to give this permission to the app. And then the text file will be saved. Here we are. Let's go back to turning patterns. Turning patterns. So jaw turning. The same. You can select a material. You can select a radius or a chamfer. You can set the data and add a module to the list. Also, you can choose between a compensation program and cutting edge radius. Cutting edge radius should be set everywhere. The code G42 is used for finish cut. This is the correction of cutting edge radius. You can see it here. But if you use a compensation program, there is no code G42. Moreover, you can use base turning pattern. Let's have a look at the patterns. Everything is very convenient and fast. There is nothing unnecessary. Cutting. The list. For example, you can see the code of turning cutting. Going on. There are lots of patterns. We don't have time to have a look at all of them. But at least briefly. Also, there is groove turning. The same, you need to set parameters and select a material. If we want to convert millimeters to inches, we need to tick it and insert. You can see the result. Millimeters are converted into inches. Moving on. Let's have a look at free contour turning, inner and outer turning, and also face turning. Let's look at outer contour turning. Here you also can select a material. You can choose between phonic or test cements. Also, you can set a correction. Let's set a starting point and lines based on a sketch. For example, the following numbers: the angle 45 degrees. We need to set the arc, big or small. And then we insert the data. For example, 90. If you want to add the code manually, you can use a keypad. But I don't recommend it because it's easier to use the lines and the arcs in the database. This way the result will be more accurate. For example, 30. If you've given incorrect data, you can delete the line and set new parameters. Here we are. You can look at the module and at the program. You can edit or change anything you want. And then you save the program text to file. Moving on. Mill turn patterns. We use hexahedron milling more often. Also, there is a subprogram. There are lots of milling patterns. We cannot get a good look at all of them. Let's have a look just at some of them. Drilling and milling with a bolt head. We can choose between phonic or height and height. We need to set center point, diameter, and number of holes. If you want to make a head accommodating hole, then set all parameters: diameter, depth, step. You can see the codes in the list. Let's move on. You can see a similar pattern. Drilling on a square. Let's press on pocket. It's very convenient. Rough milling, finish milling. Moving on, the holes. You need to set the center point. Let's have a look at the list. The first function is finish milling, second one is rough milling, with the following finish milling. We shouldn't forget to set a diameter. For a rough milling, and then a finish milling. And then processing without radius compensation. The same, rough milling and then finish milling. There are milling cutters which don't have mill radius. That's why it's convenient to use this function without compensation. And the third function is 3D processing. It's a finish processing along the 3 axes. It's also convenient. And the quality of holes is better and higher. Moving on. You can work with various polyhedrons. You can see different patterns. Let's have a look at this pattern. This pattern helps to cut rectangular or square slots. You need to set parameters and calculate the code of a program. 3D processing. Here you can choose between an end mill tool and ball mill tool. And then calculate their code. You can set standard, constant parameters, or you can set unusual non-standard radius. This is very convenient and fast. R3 radius, 1 for example. This is useful for pressing. Let's have a look at the menu. It's very convenient to make calculations for old universal machines, step by step. This is a very useful function. You can set the center point. It's very useful for the old machines. Let's have a look at another pattern. The arc. You can also make calculations. This all is very convenient. a standard triangle or rectangle. That's always useful for work. It's possible to calculate a height. It's possible to calculate crossing of two diameters. You can see the thread table. You can find the thread diameter for cutting. This will help to choose a drill. For example, thread diameter 6. You can take a drill 5-1. You need tap drill. You can see the thread diameter in inches and different functions. That's it for today. Thank you and goodbye.